So number 6 asks us to do this again. It says, well, if g of x is the result of this integral, right, what is it? And once again, this is one that we cannot go through the root calculations. But if you notice, it's going from x to pi. So the fundamental theorem of calculus kind of requires x to be on the top. So the first thing that I need to do is I need to switch the bounds on this integral. And I need to say, well, I really need to look at this from pi to x of the square root of t times the sine of t, and this is all quantity raised to the 4th. So now the first fundamental theorem of calculus says that g prime of x is just going to equal negative square root of x sine of x quantity raised to the 4th. For 7, we want to find the total area of this curve in the region. So remember, if I just set up the integral from -2 to 2, I'm going to get the net area, but they want total area. So I have to separate out the parts that are negative from where they're positive. So if we look at this function, this is x times x minus 1, and if I set it equal to 0, I see that it's 0 at x equals 0 and positive 1. So if I set up a number line and I plot 0 and 1, I can see if I pick some values in these intervals, well, if I plug -1 into this function, I can see that I get a negative times a negative, which is a positive. So the function is positive in that region. If I plug in 1/2, well, I'm going to get a negative times a positive, and that's going to work out to be a negative. And if I plug in 2, I'm going to get 2, which is positive, times positive 1, so it's positive. So in order to get the total area, I need to integrate the positive regions and then subtract the negative regions. So I'm going to just do the antiderivative for any arbitrary a and b. Well, sorry, just integrate the function. And the antiderivative is x cubed over 3 minus x squared over 2. So that means the area of our function is going to be this antiderivative evaluated from -2 to 0, because that's a positive region. We're going to add that to the area that we get when we evaluate the integral from 1 to positive 2, and then we're going to subtract the area we get when we evaluate it from 0 to 1. So these are all the positive areas added together and subtracting off the negative. So the first term, when I plug in 0, I get 0 straight across. Minus, when I plug in -2, I have -8/3 minus 4/2. Plus, now I plug in 2, I get 8/3 minus 4/2. And then I've got to subtract it being evaluated at 1. So I get 1/3 minus 1/2. And then I'm going to have minus 1/3 minus 1/2. And when I evaluate it at 0, it's just going to be 0 again. So if we clean this up a little bit, we can try to combine our like terms. I have a -8/3, which turns out to be positive because it's multiplied by this negative sign, and a positive 8/3, so that's 16/3. 4 divided by 2 is 2, so I have a -2 times a negative, so that's plus 2. Then I have a minus 2. Then here I have a -1/3 and a -1/3, so -2/3. I have a positive 1/2, because it's a negative times a negative, and another negative times a negative, so 1/2 plus 1/2 is 1. So I'm going to end up getting 16 minus 2, which is 14 over 3. 2 minus 2 cancel, so it's 14 over 3 plus 1. So that is the total area.